Let's talk about what programming actually is and what programmers do. Programmers identify problems or tasks that are ideal for a computer to solve or to automate. Once a problem has been identified, before a single line of code can be written, a programmer must devise one or more algorithms that will become the foundations for the programs they write. An algorithm is like a problem-solving recipe. It's a list of step-by-step instructions that, when given to a computer, accomplishes a task. Here's a great video from BBC Learning that defines exactly what an algorithm is. It's sort of like the steps to brushing your teeth. Make sure that you can answer the 3 essential questions before you move on. An algorithm can be defined and articulated in many different ways. Here, for example, is a flowchart, which is used to describe a basic car parking algorithm. This represents the basic solution to a challenge. The challenge is to keep track of the number of cars parked in the lot and to make sure that the lot's capacity is not reached. With a problem firmly identified and algorithms in place to guide a solution, programs can now be written. A program, put simply, is a sequence of coded instructions. Programs solve problems or automate tasks using the computer's superior ability to perform calculations. Programming as an art and a science is the process of writing, designing, testing, and debugging software. Each part of this so-called software development lifecycle is important and cannot be shortchanged. Programmers maintain what is called source code that becomes the executable programs once they are compiled or translated into a low-level, computer-friendly language. There are hundreds of programming languages used throughout the world. When you write code, you will be using some form of high-level language to do so. A high-level programming language bears great resemblance to the written language that you use in your day-to-day life. Some of the most popular coding languages are featured here, like Python, Java, JavaScript, C++, and C#. Although you'll be using a high-level programming language to write your programs, computers will not be able to execute or understand your instructions unless they are translated or compiled into a low-level language first. The processor inside a computer can only execute so-called machine code, so your code must be compiled or translated into a form that the computer can ultimately execute beforehand. Languages are normally implemented as either compiled or interpreted languages. Both methods prepare your source code for execution by the computer, but use slightly different means to do so. Compiled programming languages require you using something called a compiler. It's a special type of program. When using a compiler, the entirety of your source code must be translated ahead of time into machine-friendly code. This can be a long process, but it only has to happen once. Thereafter, each execution of the compiled program is very, very fast. Interpreted programming languages are compiled or translated at the time the program is executed. There is no separate compilation step ahead of time. An interpreter is similar to a compiler, but it normally produces something called bytecode, which is a little bit different than what comes out of a purely compiled language. The big difference is that compiled languages have a separate compilation step that must happen for the entirety of the program before it can be executed, ahead of time. Interpreted languages are said to be interpreted on the fly because the translation or compilation process happens at runtime when you actually go to run the program. This video does a great job of breaking down the difference between compiled languages and interpreted languages. It can be very confusing, but follow along and make sure you can answer the 3 essential questions before proceeding. As programmers, we normally start in the same place. We know very little and we build from there. One interesting phenomenon, however, is the fact that regardless of what language you speak or your country of origin, nearly all programmers write the same first program, and it's called Hello World. Hello World is the simplest program that you could possibly imagine. All it does is outputs the message, Hello World, to the screen, and that's it. If you want to see an example of the Hello World program, in hundreds of different programming languages, then check out this Hello World collection. This will give you some great insight into the variety of programming languages that exist and how a small, simple program can differ so much between each language. I'm going to take a moment to demonstrate this Hello World concept to you, and in the process, show you the difference between an interpreted and compiled language. So I am writing a couple of programs. The first one is a Python program. If I wanted to write Hello World in Python, it would look this simple. A simple call to a print function telling it to output to the screen Hello World. And then to run that, all I have to do is send it to the interpreter. It will execute the program after interpreting it, and the result to the screen is Hello World. Now, let's say I was working in Java. Java is a more complicated language, and it's a compiled language. In this particular case, I had to create a class called Hello World, and then there's one method called main, and this is the method that executes when I execute the class. Inside of that, you'll see one line that says system out println Hello World. This is the part that's telling it to print Hello World to the screen. Now, I can't just execute that. I have to compile it first. So using the compiler, I compile the program. If you look at the results, you'll see that's gobbledygook, because this is closer to what the Java virtual machine needs. And then to execute it, I can use Java and just say Hello World, and there we go. So you can see that there's a difference between writing something in an interpreted language versus a compiled language. And you also got to see that Hello World is the same no matter what language you're writing in.